Hi, welcome to this session on Mathematics Chapter 2 Polynomials for Class 10 Grade 10. We are doing division algorithm for polynomials exercise 2.4 question numbers 4 and 5. Question number 4. If two zeros of the polynomial x raised to power 4 minus 6x cubed minus 26x square plus 138x minus 35 are 2 plus minus square root of 3, find other zeros. Answer. We know that if k is a zero of a polynomial, then x minus k is a factor of that polynomial. Therefore, in our case, x minus 2 minus square root of 3 and x minus 2 plus square root of 3 are factors of the given polynomial. Also, the product of the two factors is also a factor of the polynomial. Therefore, in our case, the x square minus 4x plus 1, which is a product of the two factors x minus 2 minus square root of 3 and x minus 2 plus square root of 3 is also a factor of the given polynomial, this one. So now we can find the remaining factors, that is we will be able to find the remaining zeros by dividing the given polynomial by x square minus 4x plus 1. So we keep the x square minus 4x plus 1 in the divisor place here, and the given polynomial is kept in the dividend position inside the division symbol, and all the steps to carry out the division are shown here, and we can find that the remainder is 0 and the quotient is x square minus 2x minus 35. Based on the division that we just carried out above, we can write the given polynomial, and you notice that this is the given polynomial. And we can write this polynomial to be equal to x square minus 4x plus 1 multiplied by x square minus 2x minus 35. And when this is simplified, we get x square minus 4x plus 1 multiplied by x minus 7 into x plus 5. And you would notice that the first part of the equation, and this is the first part of the equation, gives us the zeros as 2 plus minus square root of 3. But in order to get the other zeros of the polynomial, let's equate the remaining part of the above equation, and this is the second part or the remaining part of this equation. And now let's equate this to be equal to 0. So we shall have to equate this part, x minus 7 equal to 0 and x plus 5 is equal to 0. And when we do this, we get x is equal to 7 or x is equal to minus 5. Hence we can say that the other two zeros of the given polynomial are 7 and minus 5. Now let's do question number 5, which states if the polynomial x raised to power 4 minus 6x cubed plus 16x square minus 25x plus 10 is divided by another polynomial x square minus 2x plus k, the remainder comes out to be x plus a. Find k and a. In our case, we are given dividend to be equal to this polynomial, divisor to be equal to this polynomial, and the remainder is equal to x plus a. We know that dividend is equal to divisor times quotient plus remainder. Therefore, in our case, we get this equation, and when we rearrange the expression, we get quotient is equal to x raised to power 4 minus 6x cubed plus 16x square minus 26x plus 10 minus a whole divided by x square minus 2x plus k. So this equation, that is this one, implies that the polynomial x raised to power 4 minus 6x cubed plus 16x square minus 26x plus 10 minus a, when it is divided by x square minus 2x plus k, the remainder should be equal to 0. So let's carry out this division. And here we show the division. X square minus 2x plus k is divisor and the dividend is this entire polynomial. We carry out the division and we see that the remainder term is this, that is minus 10 plus 2k times x plus 10 minus a minus 8k plus k square. Therefore, in our case, the remainder will be 0 if both the terms of this expression are 0. So now let's try to equate them to 0. The first term we have is minus 10 plus 2k times x is equal to 0. So this implies k is equal to 5, And the second term is that 10 minus a minus 8k plus k square is equal to 0. And when we simplify this expression, we get a is equal to minus 5. Hence we have found out the answer because we set out to find the values of a and k, which we have found to be a is equal to minus 5 and k is equal to 5.